Hello, it's What the Doodle here, and in this session, I wanted to go over an old article, and it's this one here, which is Modern JavaScript Explained for Dinosaurs. So this came out, well, as you can see here, 2017, and the reason I wanted to see this is because I just want to see how, in terms of how modern front end, how that web application development has kind of certainly front end web application, how that has evolved or how it is now, and how just to see how much of this really holds, and just how much improvements or perhaps not improvements have been made since that point. So it'll be an interesting sort of dive through that. So let's read through this. So the comics was all this what kind of reminded me as well of it. So there's a little joke here that says front-end devs used to just need HTML, CSS, and JavaScript. Now apparently they need to learn about Node, NPM, Grunt, Gulp, Webpack, Babel. Wait up, what the heck do I need Node for on the front end? So it says here, learning modern JavaScript is tough enough if you haven't been through there since the beginning. The ecosystem is growing and changing so rapidly that it's hard to understand the problems that different tools are trying to solve. So this is, I'd probably say, this is a continuing theme. The JavaScript ecosystem absolutely has been, at a breakneck speed in terms of constant churn and new innovation happening. And I think that was true then, and I still believe this. It still hasn't ended, and we are still going through that. Although I think what's happening now is that things have started to solidify a little bit in terms of the direction. Because back then, I think the biggest thing was, or the shift was, that all of the JavaScript tooling in the ecosystem was also written in JavaScript, and as of late or more recently, we've started to see a shift, if you like, towards using native, moving away from actually having those toolings in JavaScript. And this has come about, organically as the projects have kind of grown bigger and larger in complexity. What has happened is that we've found that there's a lot of, in terms of performance, it's very large projects don't really struggle essentially, and in order to solve that problem, the only way they could do that was to actually move away from building the tools in JavaScript itself. Now, of course, that may have brought some of its own challenges, but overall, we've seen huge kind of speed ups, and also, as a consequence, quite a lot of reduction in terms of the complexity. Because obviously, when you have a JavaScript ecosystem and tooling written in JavaScript itself, along with all of the dependencies and everything it needs, when you have essentially a compiled static binary, or when you have tooling that's compiled down to a binary, it removes so much complexity, or it tends to remove quite a lot of that complexity, and that's where more and more of the JavaScript ecosystem has more recently started to move towards. So anyway, let's carry on reading this a little bit more. So it says, I started programming in '98, but only began to learn JavaScript seriously around 2014. At that time, I remember coming across Browserify and staring at its tagline. Browserify lets you require modules in the browser by bundling up all of your dependencies. I pretty much didn't understand any word of this sentence and struggled to make sense of how this would be helpful for me as a developer. Yeah, because up until that point, we were essentially still doing raw vanilla. Well, probably I think jQuery was definitely a thing around that time, I think. And most of that, in terms of dependencies, the way that we managed it back in the day, they were just essentially links. Really, that's all they were. They were just you'd have a script tag and link JavaScript that way. That was the bad old days. And of course, then Node came along and popularized the whole idea of require modules. The idea that you can import, because the actual import wasn't there. It was a lot of these features obviously weren't there back then at the time. JavaScript was very 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 basic, and so when Node comes along and then brings essentially the ability to import, so that kind of starts feeling like a real programming language, or certainly like most of the mainstream languages, you import libraries and libraries and frameworks and whatnot. And so when people got used to that on these, when they started to do JavaScript on the server side, they wanted, quickly, they got used to that and customized, and they wanted all of those benefits effectively on the client side. And really, I suppose this is kind of the beginning of that innovation and that trend of complex tooling for the front side. I suppose this article is correct. This is kind of treading through that history in some ways, and this author has obviously identified that this probably was kind of the tipping point. So anyway, let's carry on. I pretty much didn't understand why a word in this sentence struggled to make sense of how this would be helpful to me as a developer. The goal of this article is to provide a historical context how JavaScript tools have evolved to what they are in 2017. So now we're in 2024. So let's see how much of this still is relevant. We'll start with the beginning and build an example website like the dinosaurs did. No tools, just plain HTML and JavaScript. Yep, that's how we all did it in Notepad++. Then we'll introduce different tools incrementally to see the problems that they solve at the time. With this historical context, we'll be better able to learn and adapt to the ever-changing JavaScript landscape going forward. Well, yeah, that ever-changing landscape, JavaScript landscape, hasn't really changed. Let's get started. Update, I made a video of this article. Okay, yeah, we could potentially look at that later. So using JavaScript the old school way. This is what I like. Yeah, this is what I remember when we used to edit raw JavaScript in Notepad. So yeah, you have your meta, your head, and then you include your you sort of reference your JavaScript files and also your CSS files as well, external files, and then the line. So let's have a look. Let's start with an old school website using HTML and JavaScript, which involves manually downloading and linking files. Here's an example, index.html file that links to a JavaScript. Well, it links to an external file that's relative. So this would be in the same root. So this would be relative right next to that index HTML file. The line script's source, or SRC, equals index.js refers to a separate JavaScript file or external one in the same directory name index.js, because this is a relative path. It could also be a entire URL, so it would be an absolute path as well. That's just to obviously he's talking about a relative external file. Index.js, so inside the index.js file is doing console.log hello from JavaScript. This is all you needed to make a website. Now let's say you wanted to add a library someone else has written, like moment.js, a library which can help format dates in a human readable way. For example, you can use the moment function in the JavaScript as follows: moment.start of day from now, and I'll give you 20 hours as an output. But this is only assuming you include moment.js on your website. On the homepage for moment.js, you see the following instructions. So you can download it. It's all minified, or it says moment with locale. So this is slightly larger, but this includes, I guess, different time zones and whatnot. And then you can install it using npm yarn spm. Is that, oh my god, that's from I think that's, I don't even remember that SPM. Meteor and Bower. God, these are really ancient stuff. Out of all of this, to be honest, I think npm and yarn obviously are still. This is NuGet. Did anybody actually use NuGet to install? That's crazy. I didn't know that NuGet. Well, I know that's part of C# and .NET. .NET world. I had no idea that could actually pull down JavaScript files. That's a new one. That's a today I learn. But anyway, out of all of this stuff, most of this I think is dead. I don't think anybody uses it. The only thing really today in 2024 still is active and used is npm and yarn. Yarn sort of is, I guess, supposed to be a faster alternative drop-in replacement for npm. Weirdly, I mean, I haven't really played around with it. I think a lot of the stuff that yarn solved in terms of speed and all this kind of stuff, a lot of the benefits were eventually folded back into npm, and so I think the de facto, even to this day in 2024, is npm. I could be wrong. I'm sure there's die-hard fans of yarn, and I'm sure they'll be screaming at the moment. So it says here, there's a lot of stuff going in the install section on the right, but let's ignore that for a moment. I think nowadays, if you go to most places, I think they'll probably just have npm. I think all this stuff, there was an incredible different amount of ways of doing it. I think these days, pretty much you'll just see npm and yarn. So I think. Actually, in fact, that would be interesting to go to the Moment.js homepage. What do they have now? No, they still have it. They still have all those other ways. That's quite surprising, actually. 2.3, let's see, what did they have at the time? He doesn't actually mention what version was in 2017. But anyway, okay, that's surprising. I thought they would just, I mean, most places you just see npm or yarn, to be honest, references. Anyway, so, okay, so there's a lot of stuff going on, blah, blah, blah. But let's ignore that for now. We can add moment.js to our website by downloading the moment.min. So this is the minified version file in the same directory, including it in our HTML file. Fairly straightforward, right? So you include it, and you have to make sure you include it in terms of the order that it loads it. So you'd load that ahead, and then you'd load in your application or whatever your particular JavaScript code. So note that moment gets loaded before, yeah, there you go, he's mentioned here, which means you can use the moment function in the index.js as follows. So in your application code, in your JavaScript code, you'd write something like this, and then console.log.moment start of day from now. Now this is how we used to make website with JavaScript libraries. Yes, the good old days. The good thing was that it was easy enough to understand. The bad thing was that it was annoying to find and download new versions of libraries every time they would update. Yes, absolutely. So using a JavaScript package manager, npm, which is effectively the de facto standard even in 2024. Starting around 2010, several competing JavaScript package managers emerged to help automate the process of downloading and upgrading libraries from a central repository. Bower was arguably the most popular in 2013, but eventually was overtaken by NPM around 2015. It is worth noting that starting around late 2016, Yarn has picked up a lot of traction as an alternative to NPM's interface, but it still uses the NPM packages under the hood. Don't know if that's still true. So note that npm was originally a package manager made specifically for Node.js, a JavaScript runtime designed to run on the server, not the front end. So that makes it a pretty weird choice for the front end JavaScript package manager for libraries meant to run on the browser. True. Note, using package managers generally involves using command line, which in the past was never required as a front end dev. If you've never used one, you can read this tutorial to get a good overview to get started. For better or worse, knowing how to use the command line is an important part of modern JavaScript, and it opens up the doors to other areas of development as well. Yeah, I think that's an interesting point. You know, I never actually thought about that because so prior to, I think, around 2011 or thereabouts, I was slowly transitioning over from the Windows world into Linux, and obviously, the rest is history, and I've been using Linux ever since. So it's been so long that I've completely forgotten, 99% of the stuff, in terms of how that development under the Windows world was. Obviously, I'm not anything against people who use Windows and whatnot, or who do software development there, but I think once you make that transition, it is very difficult to kind of go backwards in that sense, because it's a completely different way, it's a different world of development, and I think it's just the productivity just goes off the charts. And I had never even, just reading this part of it, the fact that that is command line driven, and obviously so it's really weird because in terms of web development, I'd personally made that transition from Windows over to Linux, and of course the Linux world is all very much CLI driven. Not all of it, of course. We do have UIs and desktop environments, but in terms of development and all that kind of stuff, it is very much CLI oriented. And I hadn't made that connection that actually the web development part of it had shifted towards and being very CLI first. I really hadn't made that connection. And just rereading this is interesting, and I think, I hadn't made that connection, but I can see now it kind of makes sense. So perhaps those who were, still not being, I think, it must have forced a lot of people to kind of think in a different way and approach the tooling as well. Probably why there's, I don't know, maybe that's why development under Linux, obviously I can't tell you what the experience is like in terms of doing front-end web development in a Windows environment, because that's not an environment that I'm familiar with, because I've left that Windows world. But now I think I understand why things like WSL, Windows subsystem for Linux, kind of one of the reasons why, probably because of the fact that the web development was so geared towards, web development was so pro CLI, and the most, if you like, the most natural experience of that, or the most the first class citizen experience of that would have been under in environments such as Mac OS or Linux. And so yeah, now yeah, I can see why Windows had to, in order to even to sort of keep up, I guess, had to effectively put an entire Linux kernel into the Windows operating system just to kind of keep up with. And I maybe the web development was kind of the spearhead for that. I don't know. That'd be another interesting to look into a little bit more. Okay, let's look at how to use npm to install the Moment.js package automatically instead of manually downloading it. If you have Node.js installed, you already have npm installed, which means you can navigate your command which means you can navigate your command line to the folder with index.html file and enter npm in it. This will prompt you with several questions. The default's fine. You can hit enter for each question and generate a new file named package.json. So that's the project manifest. And in 2024, we still have this. So this is all, it's all identical essentially. And it even has like task runners and all that kind of stuff as well. And npm install moment --save. You can also save the difference between development dependencies as well as actual like dependencies, and you can also, I think, install dependencies globally system-wide, because npm will work on a per project basis or per folder basis, so it doesn't make the assumptions that the kind of various dependencies that you install for that particular project they won't. There isn't like the central place that it installs it, and that's great actually. Great in one sense, but also bad in another sense in terms of space, because it means that because of the, node dependencies as a whole running theme and meme and a joke around that in terms of just the insane amount of dependencies that it installs and how much space it takes up. So of course you can imagine that if you have lots of projects on your machine, then yeah, it can take up a heck of a lot of space. So anyway, so it says here, this command does two things. First, it downloads all the code from the moment.js package into a folder called node modules. Second, it automatically modifies the package.json to keep track of the moment.js as the project dependencies. Yep, so this is all still, I think it's called so that's dependencies for the front end, obviously the actual, your final when you compile it all down. But also you have the dev dependency as well, so there are two kind of different dependencies. Because dev dependencies are not included in the final build, if you like, because that's only used for the for your actual development environment. So this is useful later on when sharing a project with others, instead of sharing the node modules folder, which can get very large. Yep, that hasn't changed. That's still the same. You only need to share the package.json. Exactly. This is essentially like modern development, like any mainstream language. You'd have some sort of, because you essentially have a build tool chain that handles this and package manager. These are all kind of it vastly improved the way we approach front-end development, because it's kind of brought it up to kind of parity in terms of what was enjoyed in the Java world, in the C# world, and all the other mainstream server-side languages. So it's kind of like giving that same, you have a project manifest, which is metadata about all of the dependencies and setup. And of course, you wouldn't. There's no need to when you source control, you absolutely you wouldn't include those dependencies, because in theory, at least, everything that's inside the package.json, and there's also a lock file as well, by the way. That's also, you'll see in a moment. So yeah, that defines all of the dependencies essentially. Which can be in theory repeatable against different when different users use that project, when they clone that particular project, they can just run the same install command, and reading this manifest, it'll know what dependencies to pull down. Okay, so it says we no longer have to manually download Moment.js from the website. We can automatically download it up and update it using npm. Looking inside the node modules folder, we can see that the moment.min file is in the node modules /moment/min directory. This means that we can link to the npm download version like this. Yeah, okay. So the good thing is that now we can use npm to download and update our packages through the command line. The bad thing right now is we're digging through the node modules folder to find the location of each package and manually manually including it in our HTML. That's pretty inconvenient. So next we'll take a look at how to automate this process as well. So these days people use npm as a front end package manager. That seems like a questionable choice to me. How can JavaScript in the browser properly use JavaScript modules designed for the node using a JavaScript module bundler? So this is, this I think the real kind of next evolution. Obviously we had obviously Node, we had these dependencies that we started to we started to see the basis, if you like, of a build tool and all that stuff. And so as he mentioned, you wouldn't want to kind of point to file structures that then you'd have to maintain and download and all this kind of stuff. And so obviously module bundlers, and it goes on from that, because it wasn't just module bundlers. We started to do translation, because then you had it's essentially like not just only transpilations and tree shaking, and it became a whole pipeline essentially. So we'd have source files, and then we'd transform all of that into a target sort of essentially compiled files that you emit at the end of it. That's where all this kind of heads towards, because it sort of it evolved kind of one problem at a time almost. So as people as we ran into different challenges and things like that, we kind of started overcoming them bit by bit. So it wasn't like there wasn't any sort of centralized decision making, if that makes sense. It's just that people started running with this stuff, running into walls, running into problems, running into challenges, and then somebody would come up with a solution, and then people would start, or sometimes there'd be competing solutions, and just kind of like almost like evolution, the best solutions, or the ones, no, it doesn't always have to be the best solutions, but the most popular ones eventually won out, and then some of the other solutions kind of died down and didn't for whatever reason didn't get any traction, and eventually fell off and died. Where were we? Most programming languages provide a way to import code from one file to another. JavaScript wasn't originally designed with this feature, because JavaScript was only designed to run in the browser, with no access to the file system of the client's computer for security reasons. So for the longest time, organizing JavaScript code in multiple files required you to load each file with variables shared globally. This is actually what we're doing with the above moment.js example. The entire moment.min.js file is loaded into the HTML, which defines the global variable moment, which is then available to any file loaded after moment.min.js, regardless of whether or it needs access to it. In 2009, a project named CommonJS was started with the goal of specifying an ecosystem for JavaScript outside the browser. A big part of CommonJS was its specification for modules, which would finally allow JavaScript to import and export code across files like most programming languages without resorting to global variables. The most well known of implementation of CommonJS modules is Node.js. As mentioned earlier, Node.js is a JavaScript runtime designed to run on the server. Here's what the early example would look like using the Node.js module. Instead of loading all of the moment.min.js with the HTML script tag, you can load it directly in the JavaScript file as follows. So var moment require. So here's that require. Here's the required syntax here. Again, this is how module loading works in Node.js, which works great since Node.js is a server-side language with access to the computer's file system. Node.js also knows the location of each npm module path, so instead of having to require the entire relative path to there, you can simply write moment.write which is pretty sweet, because it infers that it knows, because it's relative to that file and whatnot, and it'd be one of the hard-coded paths inside of the Node.js runtime. This is all great for Node.js, but if you try to use the above code in the browser, you'd get an error saying requires not defined. The browser doesn't have access to the file system, which means loading modules in this way is very tricky. Loading files has to be done dynamically, either synchronously, which slows down execution, or asynchronously, which can have timing issues. This is where a module bundle comes in. A JavaScript module bundler is a tool that gets around the problem with the build step. Bang, there you go. The build step. This is literally like how all of this kind of this is where all of these complexities started to come in. It's because of that build step. It's complexity, but also it solves a lot of problems. And that this is what kind of what I would start to say is when we started to diverge into modern JavaScript development. It's because of this build step. It's because of this build step that we've been able to do so many things that we weren't able to do before. And it kind of separates into having what you have your source files, and you have your essentially when it's all gone through that pipeline, and then your final output files that are emitted. It's almost like you're compiling. So you have like the browser essentially becomes a compile target. So normally in mainstream languages, whether it's Java, C Sharp, C++, Rust, or whatever, you have your source files. These are the files where the actual code is, and then you could run it through a compiler, and then after you run it through a compiler, you emit some sort of either assembly or bytecode so you have some sort of target environment where that would run. And so this is what that builds up gives us essentially. And that opens up huge amounts of possibilities and innovation, as we've seen with modern web development. And even in going into 2024, we still have that from that. The difference, I would say, is that the build step, if you like, previously, all of that was so the build tools themselves were written in JavaScript, and that had its own set of complexity. And as I said, there was all sorts of competing ideas and innovation on whatnot. But now, because the complexity of the project has allowed us, by having that build tool, allowed us to build even more complex web applications. It's sort of the performance has because obviously it's written in a dynamic language and all this kind of and performance has been a massive bottleneck, not just complexity but performance as well. And in order to solve that, as I said much earlier in the session, in order to solve that, the community have started to look towards using building these tools and just building them in native low level high performance languages like, for example, Rust and C++ and Go and whatnot. And they've seen, as a result, not surprisingly, of course, huge orders of magnitude in terms of the speed at which it can do it, but also a reduction in the complexity. Suddenly you don't need all of that JavaScript ecosystem in order to have the build tool, if that makes sense, because you just have a binary as a target, and that's a lot easier to install, a lot easier to manage and whatnot, and also to use, and it fits very nicely in the command line tooling in context. So anyway, which has access to the file system to create a final output that is browser compatible, which doesn't need to access the file system. In this case, we need a module bundler to find all required statements, which is invalid browser syntax, and replace them with the actual contents of each required file. The final result is a single bundled JavaScript file with no required statements. The most popular module bundler was Browserify. Of course, we went from Browserify, then eventually Webpack, and then a whole load of other ones. So there was like Rollup, if I remember correctly, and a whole load of other ones, which was released in 2011, pioneered the usage of Node.js style require statements on the front end, which is essentially what enabled NPM to become the front end package manager of choice. Around 2015, Webpack eventually became the more widely used module bundler, fueled by the popularity of React front-end framework, which took full advantage of Webpack's various features. Let's take a look at how to use Webpack to get the above required moments example working in the browser. First, we need to install Webpack into the project. Webpack itself is an NPM package, so we can install it from the command line. Save it as a -- save dev, which means that save it as a dev dependency and not as it's for the development environment that you're working for that particular project, not as a final dependency. Now that we're installing two packages, Webpack and Webpack CLI, which enables you to use Webpack from the command line, and also note the --dev save argument. This argument this saves it as a development dependency, which means it's a package that you need in your development environment, but not on your production server. So that's the important part of the dev --save dev. You can see this reflected in the package updation. Yeah, so we still have this. Obviously, this is the final dependencies for production or whatever gets compiled down, and this is dependencies that are needed for the actual development of that particular when you're developing on that particular source code. Where were we? Yeah, which was automatically added. Okay. Now we have Webpack and Webpack CLI installed as a package manager in your node folders. We can use Webpack CLI from the command line as follows. So yeah, okay. This command will run the Webpack tool that was installed in Node modules folder and start with the index.js file, find any required statements and replace them with the appropriate code to create a single output file, which by default is dist min.js. The mode equals development argument is to keep the JavaScript readable for developers, as opposed to minified output from the argument, which is node production. Now that we have a Webpack's main.dist output, we are going to use it instead of index.js in the browser, as it contains invalid required statements. This will be reflected in the index.html file as follows. So yeah, this is your final dist, your compiled, if you like, your final compiled JavaScript code. If you refresh the browser, you should start seeing everything working as before. Note that we'll need to run the Webpack command each time we change index.js. This is tedious, and we get even more tedious as we use Webpack's more advanced features like generating source maps to help debug the original code from the transpiled code. Webpack can read options from a config file in the root of the directory of your project name webpack.config.js. And this is interesting because this something .config.js has become almost like a pattern. So a lot of the tooling within the JavaScript ecosystem started to follow this. I think in the root of that project folder, you'd see all sorts of all sorts of whatever the thing is .config.js, and all that was essentially just they just used JSON to define all of the various kind of configuration. And yeah, that's just kind of interesting. You can almost start, that's quite recognizable. And so it says Webpack can read those from those options, and like I said, look like this. Okay, and yeah, Webpack was horrendous. I remember even, still remember to this day. I'm glad we moved away from quite a lot of that stuff. It's just got so. It was doing so many things, I think, and it was always such a hassle and faff to build out that configuration. Now each time we change index.js, we can run Webpack with the command Okay, we don't need to specify the index.js and options anymore, since Webpack is loading those options from reading it from the configuration. This is better, but it's still tedious to enter that command for each code change, and will make this process a little bit smoother. Overall, this may not seem like much, but there are some huge advantages to this workflow. We are no longer loading external scripts via global variables. Any new JavaScript libraries will be added using the required statement in the JavaScript itself, as opposed to adding the new script tags in the HTML. Having a single JavaScript bundle file is often better for performance. And now that we've added a build step, there are some other powerful features that we can add to our development workflow. Browserify or Webpack. Webpack is more popular these days. It's too much. Well, it's true that things move fast in the JavaScript world, but that is what allows for innovation, which everyone benefits from. So you're saying you have to just get used to it. Maybe things are settling down as we speak. Transpiling code, transpiling code for new languages features using Babel. So transpiling code means converting the code in one language to another similar language. This is an important part of the front-end development, since browsers are slow to add new features. New languages were created with experimental features that transpile to browser-compatible languages. So I think in 2024, it's interesting. Like, there are discussions around: do we even actually still need things like? Do we still need transpiling? Simply because so many of the features that we didn't have. Modern browsers are very, very capable now, and it was always a short-term solution. The idea is that we wanted to have all these modern JavaScript features, but we wanted to be able to have be effectively backwards compatible to the most ancient browser. But even now, the most oldest browsers have quite a lot of abilities and features, and so it was always the case that over time there will be less and less need for this. And in 2024, I mean it depends what your target browser is. If you are still unfortunate enough to target something as ancient and dead like Internet Explorer 6 or something, I don't know, maybe you would still want to transpile. But if you look at the statistics over time, those dead browsers, they're like, you know, probably in the single digits or something like that, like 0.1% or something. Um, and at that point, you kind of have to ask yourself: Is it? Do you really need that level of compatibility? Um, given that there'd be so, given the market is so small and so and yeah, over time it becomes harder and harder. As time goes on, it becomes harder and harder to justify having to be that backwards compatible because I mean some of these yeah, some of these browsers are so ancient. I mean the operating systems aren't even supported anymore. So yeah, over time there's less and less need for that. Okay, so for CSS, there's Sass and Less and Stylus, to name a few. For JavaScript, the most popular transpiler for a while was CoffeeScript. Yeah, I remember CoffeeScript. And then, of course, TypeScript came along, I guess, and has kind of taken that whole world over. CoffeeScript is a language focused on improving JavaScript by. I mean, is anyone still using CoffeeScript in 2024? I mean, I possibly there might be some legacy code bases knocking around still using CoffeeScript. I feel sorry for them. My condolences. Yeah, actually, to be honest, I mean, CoffeeScript was pretty cute when it came out and kind of showed us. Yeah, I think it opened the door to TypeScript and other kind of languages because vanilla JavaScript was so horrid with so many warts and things like that that being able to write in a slightly nicer, more slightly nicer language, slightly more refined. This is what it allowed, and then that got people thinking, and definitely got Microsoft thinking, and the fact that obviously JavaScript is doesn't have any type, but I think TypeScript kind of I'm still I'm still sort of 50-50 on TypeScript because I get that like I want to like it, I really do, because obviously if you from the previous kind of sessions and videos, for those who are aware, I'm very much pro static types. But where I feel where they kind of made them, sort of the $1 million blunder, I believe, with TypeScript is that in order for it to be backwards compatible with JavaScript, they essentially use gradual types, which is to say they kind of made all the types optionals, really, because JavaScript is supposed to be a subset of TypeScript. And that I think kind of killed it really, or I think it really crippled it a lot. Because of the fact that a lot of people could, or you could essentially throw any at any point or any types or whatever, and you'd essentially throw away all the benefits that you'd get from having types, really. So I get why they did it. It's the same kind of reason why like C++ wanted to be backwards compatible with C and whatnot, and it's that same issue. Whenever you try to make something new backwards compatible, it is a lot of compromise, and I think that was too much compromise there. I think they should have just been strict and said no, TypeScript is literally going to be full on static types. That's it, not gradual. It's they did it in order for backwards compatibility and adoption as well. They wanted to slowly because obviously the JavaScript world was massive. This still is massive, and TypeScript was a new kid on the block, and they knew they couldn't just they couldn't take they knew they would have a massive uphill battle, and so they thought if we allow a slow migration path, then we can increase adoption over time, and it has worked to some extent. But I mean I've used TypeScript, and in the end I just resorted back to JavaScript. It's just too much hassle and not that much benefit from it. Now, other people's experiences may vary, and it might well be that they have they've used TypeScript and they've sort of have very much little JavaScript that interface or backwards compatible with, and they've enabled all of the strictness and security to make it behave like a fully statically typed language. But I think that might be rarer. I don't know. Obviously, everyone's mileage will vary, and everyone's approach to their projects will vary as well. So anyway, That's obviously a side tangent. CoffeeScript is a language focused on improving JavaScript by significantly changing the language, optional parentheses, significant whitespace, etc. Babel is not a new language, but a transpiler that transpiles next generation JavaScript with features not yet available to all browsers, ES 2015 and beyond, to older, more compatible JavaScript, ES5. TypeScript is a language that is essentially identical to next generation JavaScript, but also adds the optional static typing. Many people choose to use Babel because it's closest to vanilla JavaScript. So he goes on and on here. So I'm going to skip past a lot of this stuff. Yeah. Let's have a look. So still using Webpack. Yeah, then we had the whole asynchronous await. Yeah, then we come to task runners, which we still have. So you can. It just makes things a little bit easier because you can run npm and then you can call those tasks essentially, and then in those tasks you can have so you can add a little bit of automation in there, so that's fine. So then you can have this nice kind of npm run and then the task that you want to run essentially, which is good. We still have that, of course, and let's have a look. Notice that the scripts and packaging can run Webpack without having to specify the full path since Node.js knows the location of each npm module path. This is pretty sweet. Yeah, we still have this. We can make things sweeter by installing Webpack Dev Server, a separate tool which provides simple web server and live reloading. Yeah, so yeah, we started to move and start installing other things like web servers, development web servers as well, and this is starting to look very similar to modern web development that we have in 2024. And so you can just do npm run server. Let's have a look. So conclusion. Let's read the conclusion here. So this is modern JavaScript in a nutshell. We went from plain HTML and JavaScript to using a package manager, to automatically downloading third-party packages, a module bundler to create a single script file, a transpiler to use future JavaScript features, and a task runner to automate different parts of the build process. Definitely a lot of moving pieces here, especially for beginners. Web development used to be a great entry point for people new to programming, precisely because it was so easy to get up and running. Nowadays it can be quite daunting, especially because the various tools tend to change rapidly. Yeah, that's true, but I think they're starting to now stabilize a lot more now. I don't think that, yes, there's a lot of innovation going, but it isn't as crazy as it was, and we've started to solidify down to a few of the key players, or a few key tools. Still, it's not as bad as it seems. Things are settling down. Yes, that trend has continued, but I think it's not only settled down, but also, as I mentioned, it's pivoted. It's settled down, but the big pivot was towards moving away from using building the actual build chain and all that stuff in JavaScript itself. So we moved away to using static languages such as Rust and Go and C++ to build our build tools essentially. So that's been one of the biggest shifts. That's mostly because originally as I said earlier, it was for a performance reason, but it has had many positive effects as a result. So particularly with the adoption of Node ecosystem as a viable way to work with the front end, it's nice and consistent to use npm as a package manager, Node require or import statements for modules, and npm scripts for running tasks. This has vastly simplified the workflow compared to even a year or two ago. Even better for beginners and experienced developers alike is that frameworks these days often come with tools to make the process easier to get started with. Yeah, so we have all of these tools, and even those things I think have started to coalesce into a more unified tooling now. All these tools will be all these tools will set up a project with everything you need. All you need to do is start writing code. However, these tools aren't magic. They simply set everything up in a consistent and working fashion. You may often get to a point where you still need some extra configuration with Webpack, Babel, etc. So it's still very critical to understand what each of the pieces does, as we've covered in the article. Modern JavaScript can definitely be frustrating to work with as it continues to change and evolve at a rapid pace. But even though it may seem at times like reinventing the wheel, JavaScript's rapid evolution has helped push innovation such as hot reloading, real-time linting, and time travel debugging. It's an exciting time to be a developer, and I hope this information can serve as a roadmap to help you on your journey. So yeah, I mean, so although this was in 2017? Let's have a look. Let's go back. So this was in late 2017 to 2018, just before COVID and whatnot. But Yeah, a lot of it is very it's still very similar to now. As I mentioned, the big change from there really is the fact that we have sort of the tooling itself has started to be written in static languages, and actually the one that I use nowadays is Vite. I mean, it's called actually let me show you Vite. It's pronounced Vite. Apparently, it's a French name, or it's a French word, and next generation front end tooling. Um, and with Vite, you can obviously do most of the package. Most of the different frameworks and whatnot. Um, has a everything is it's all bundled into one, and that's what I like about it. It's all self-contained, so it has a built-in development server. It does hot module reloading and all the plugins and everything. It does all the optimization and the building and everything, and everything's sort of built out. It's all like that whole out of the box experience is really good. Of course, I use of course this can be used for React and whatnot, but the framework that I really like out of all of them, and I know this might be a bit quite opinionated, and it is the smaller underdog, but I like Vue a lot, and obviously that's not surprising because Evan Yu, so the creator of Vue, is who created Vite. Sorry, not Vite. Sorry, apologies. It should be Vite. And I can quickly show you Vite. Let's make this a little bit bigger. So what we'll do, let me just clear the screen, go to the desktop, and we just do npm create and Vite at latest. So we're gonna use the latest. So this is let me just make it even bigger a little bit. Yeah. So I just wanted to show like in terms of how quickly like the modern development is. It's not like how it was before, where there's so many steps and things involved. Everything's all built in and everything's out of the box. So the very first thing is we execute this command npm create Vite at latest. So we do that, and that will then ask us, okay, what's the name of the project? So we just say, let's just say super app. I don't know, doesn't matter. And then it gives us the options. Do you want it just vanilla, just raw JavaScript? Vue? Do you want to use React? Do you use Preact? Lit? Svelte is there as well. Solid and Kwik. Never heard of that. And I presume there's a whole load of other ones bundled. A whole load of other templates that you can use. So I'm going to go with Vue. And as I said, I mentioned earlier, you can obviously go ahead and set up for TypeScript. But I've used TypeScript. This is just a personal thing. I used TypeScript, didn't like it, and gone back to JavaScript. So I tend to go for JavaScript. And that is it. That's done. That entire project is set up. We can, as it says in there, all you have to do is you need to go into the actual folder, run the install, so that install all the dependencies, and then run development. That's all you need to get up and running. So let's do that. Let's jump into that, and we can have a look. So this is all the stuff that is already created for you. Everything's all set up and done for you. So the very first thing is actually what we'll do is we'll run up Visual Studio Code. So we'll bring that up. It'll make it a little bit easier. So Visual Studio Code is up and running. Let's close that and make that full screen. So we can have a look at main.js. Oops, hang on. So this is our main. Oops. Let's have a look at app. Yeah. So this is our actual app. Our app code once it loads up. Okay, and let's toggle the terminal. Let's just make that a little bit bigger. So all we need to do is npm install. So this is to install the dependencies, and it'll go ahead and install everything that it needs for this particular project. You need to do that once. Or if you've cloned it down, for example, you'd install the dependencies initially. As you can see, our node modules has been populated and done. And look, it's pulled everything down. Obviously, my internet connection is terrible, and it took longer. And I'm running inside a virtual machine as well, so the disk isn't all that great. But generally, on my main workstation, this is like seconds, pretty instant. So, and then after that, we just do npm run dev. And there you go, that's it. So now if I click, that's actually built, everything is up and running, ready to work on. So I can click on that, and if we go back to our web browser, we can see, look, this is the entire project, all compiled, built, hot module reloading. It's all running. Everything's been set up. That was trivial, absolutely trivial to do. And this is a full-on working application. Look, it has, we can go and edit this stuff. I could just say is super awesome. So if I save that, it's, as soon as I save it, it's instantly updated and reloaded, and look, it's completely reloaded, and the state is still there, and there wasn't any hard browser refresh that was needed. But it's just amazing how far we've come. And obviously, if we go back, if we just shut this down for a second, and we do npm run build, and now it's actually bundling and building everything, and there you go, look, it's done. And so it's built everything, it's zipped it all down. And if we look at the dist folder, here, so we've got the assets, and just want to have a look here. So yeah, it's bundled down the CSS, the index, and the actual JavaScript itself is here. Oops, I'm not going to open that. So let me just go here. If you go into the dist folder, and we go into the assets, I just wanted to see how big that was. Yeah, everything has been boiled down to 56 kilobytes, and of course when it's gzipped, so when it goes over the wire, it's 22 kilobytes. The CSS itself is 0.65 kilobytes. It's all been, the HTML is 0.29 kilobytes. It's all really super optimized. Obviously, you can go in and play around with the configuration and stuff like that, and optimize it to death and even further. But it is amazing how far we've come, and just the speed at which and then the speed at which you can do modern development. I know modern web development gets all this flack about it being complex and all this kind of stuff, but it actually isn't. It isn't all that. I mean, it can be complex, but it depends on each project and how it's set up. I think some of that complexity, and this is my personal opinion, I think a lot of that is actually coming from the React world, and I think React has just become more and more complex over time. But I think that's more of a framework issue, or actually, well, React obviously isn't a framework; it's a library. But that's more if you happen to pick that particular library, and that's not all the same for other frameworks. For example, I believe I believe out of all of them, I think Vue is the nicest. But then obviously I'm biased. I have actually used all of the different frameworks / libraries, and for me, and this is my own personal opinion, I found Vue to be, of course, I know in the industry it's kind of the underdog, as I mentioned before, but I found it to be sort of that nice, it's that sort of nice sweet spot, if you like. It's not overly complicated, but it's not underpowered. I think it seems to have the best of all the different other frameworks, all kind of sort of condensed down into this framework. And that's why I personally like Vue. And I think once you combine Vue with the tooling that is Vite together, it is super awesome. And for me anyway, I just love working in that environment to do essentially modern front end development. Such a smooth experience, and I continue to use that particular combo. And I think going forwards, as more and more, I mean, as many more of the tooling and things go towards having a static build, static tooling, or static binaries for the toolings, as we have more and more of that, I think it will just improve. I think even more, and things will simplify even further. I think it's pretty decent, and obviously even the editor and everything with all of the kind of different plugins that we have. In terms of IntelliSense, almost like we do have IntelliSense, and all of the linting, the real-time linting and formatting, everything. It is a really nice in modern 2024, the experience is very, very smooth. I would say it's not as rough and ever changing as it was previously. As I think in 2017, a lot of things, that we take for granted in 2024, for example, a lot of that stuff was just it was a sort of, it was getting there, but I think we're a lot closer to, in terms of in terms of the development. They call it DX, which is development experience. I think that the developer experience is pretty strong in 2024, but of course, as I said, everybody's experience is different. For me, it's, I'd say, where we were in 2017 to where we are now, this is a big difference. It was a lot more headache and a lot more setup and a lot more complex. So a lot of those arguments about web development being overly complex, I think a lot of that is around that time and earlier. But I think a lot of those complexities, we don't actually have a lot of that now as we did before, because the experiences have improved so much. Because things have a lot of those challenges and issues have been overcome, I believe, and I think going forward it will continue to improve, I think. So anyway, so that's where I'm going to leave it here for this one. So until next time, I'll see you on the next one.